out along key freight corridors. Please let me know if you'd like more information there as well. And then I will also note that NASEO has our Energy Policy Outlook Conference, or EPOC, coming up in a few weeks in DC. The draft agenda is online if you want to check that out. And if you're not registered yet and are planning to come, please go ahead and get registered as soon as possible. That's it for me. Thanks, Delaney.
Thanks, Jesse. And of course, I forgot to click record, but we haven't got to the presentation yet. So that's the most important part that is recorded. But this call will obviously be recorded. So we'll send it out to you guys once we get that uploaded to our YouTube. But I'm excited to hand it over to Elizabeth to tell us a little bit about the findings from their recently released report. We'll have time towards the end for questions, discussion, but in the meantime, if you do have questions that pop up, feel free to put them in the chat and we can get to them later on or whatever Elizabeth's preference is. But with that, I'll hand it over to you, Elizabeth.
Unmute should be in the bottom left of
There
your
we go.
screen.
Sorry.
No worries.
I popped up my windows right at the wrong time. Hi everyone. Can you all see the correct slide here or what you think is the correct slide?
Yep, it looks like
Okay.
the title page. Yep.
Great, great. Sorry, I'm a Teams girl. So the Zoom functionality, especially with the slides, is always a little bit tough for me. Well, hi everyone. My name is Elizabeth Turnbull, and I am the Director of Policy and Regulatory Affairs for the Alliance for Transportation Electrification. And here to talk a little bit about a recent white paper that we issued on a bunch of different approaches to distribution capacity constraints, which is about when I start talking about it, it's about when my mom falls asleep. But it's actually, as I think many of you probably know in your work, a really important, um, uh, increasingly an impediment to getting EV charging stations installed. And so something that we wanted to explore because there are a lot of new and interesting approaches that utilities are exploring. And Delaney, will you just remind me how much time I have here?
Yeah, so you can take up until, the last up until 3:45 if you'd like, or yeah, as long as you have like 15 minutes or so for questions and discussion, that would be great.
Great. Okay, thank you. So just a brief background on ATE. We are a trade association based in Seattle, Washington, though I'm actually based in Oregon. Oh, hi, Mary. I see you out there. Um, so we're a trade association of utilities and automakers and charging hardware and software manufacturers and all sorts of others in this space who are really working towards an electric future for transportation. Our policy principles really center around a strong role for utilities in particular in that transition. And we do a lot of sharing of best practices for utility programs and things like that. We also advocate for interoperability and open standards. And I know a lot of folks here on the line have been involved in NEVI work and things like that. That is stuff that we track closely. But I will say that our primary point of intervention in the whole cycle is in the state regulatory space, so with public utilities commissions. We see that as a really important lever for getting a lot of this work done. And we've been around since 2018. I joined just over a year ago. And so we have a lot of thought leadership in a couple of different important areas. As I mentioned, utility program design is a big one where we talk about what that utility role is and can be, sort of what are the choice points, featuring case studies of our utility members. We also talk about rate design, right? As I think many of you know, particularly for DC fast charging, the way that utility rates are structured is really important to how profitable those stations can be or how well they can serve their fleet customers. So we have a lot on rate design. And then interconnection or the energization process. Again, I think that's probably familiar to a lot of you as a challenge in this space. So we have a handful of white papers all addressing this question of energizing EV charging stations. And Delaney, maybe you can send around the slides afterwards. But all of these are links, so you can link to some of these resources that we have. And it's this darkest blue in the front on the interconnection side that is our most recent paper that I'll be speaking about today. And it came out just last month. So I just want to sort of level set when we talk about grid capacity in the context of this paper and generally in the context of EVs, we're mostly talking about distribution system capacity. I think there's sort of a lot of questions swirling around the country of like, do we have enough power generation to support EVs? What about transmission lines, right? There's a lot around transmission, data centers, things like that. By and large, I think that EV charging sites are a question mostly of distribution capacity. Like we probably have enough power generation to serve them. Transmission, generally, yes, right? Maybe no on the data center side, but for EV sites, they're not triggering generally transmission upgrades. But it's really this distribution grid, everything from the distribution substation downstream, that can be a real challenge in getting EV charging stations installed. So I put together a little graphic of the typical utility service connection process. And I say typical, again, I know that all of you know that this is a very complex process and can take a lot of time. And that's one of the things that we wanted to address in this paper is exploring some of the ways that utilities are taking less time or working towards that. So typically, we start over here on the left with a service application from a customer, and then the utility conducts an engineering review. And then either the distribution capacity at that site is available, right, based on the size of the wires coming to that site already and the load that's already on those wires from existing customers, or it is not available. If the capacity is available, then a service extension is constructed to connect that site to the grid. I just want to pause and say that process alone can take a lot of time. So when we hear about transformer shortages, when we hear about permitting timelines, the energization queue at the utility, a lot of those have to do with just like constructing that service extension. If the distribution capacity is not available, then in addition to doing the service extension, we also have to do distribution capacity upgrades. And that's when we start to trigger the like years and years potentially of delays. And when we talk about the constraints in the distribution system, that's the piece that we're talking about and easing the timelines in that area. Unfortunately, we're not going into anything regarding permitting or transformer shortages in this particular paper, though we have addressed those in our prior papers. And so in this paper, I wanted to break down really these two different reasons because they're quite distinct for a lengthy energization timeline. So when we have a distribution system capacity constraint and need upgrades in that area, that's really the utility preparing to serve that load, right? When it's just a service extension construction, that's just connecting the load to the grid. But the distribution system upgrades really are around making sure that the grid can serve that site. The constraints look like substation capacity or feeder capacity versus some of the other things that I talked about, right? The permitting, the transformer availability, that's really more in the service extension constraint bucket. And the timelines are really different here, right? So the service extension process, as you know, can take a couple of years. We know that that's held up a lot of fast charging sites over the years. Distribution system capacity upgrades are in like a whole different ballpark in terms of the time that it can take. A feeder upgrade, a substation upgrade, which can take 7 to 10 years, all of these things being planned. And of course, these things are orders of magnitude more costly as well. And so when we think about the solutions to these two different types of timeline delays, um, the a lot of the solutions fall into this service extension construction bucket, right? It's the process improvements within the utility. It's additional utility personnel to sort of like push the paperwork, right? Pre-ordering equipment so that you have those transformers on hand, the permitting reform. When we're thinking about distribution system capacity upgrades, that's where the solutions that we explore in this paper are really coming into play. And I'm going to get more into those details. So I also want to make sure that we're sort of centering ourselves around what are the risks associated with energization timeline delays, right? Because it can seem like it's just, well, you just wait a few years. But, in reality, that has impacts for all of us. When the utility faces potentially canceled or lost projects, they lose that revenue. When the project is delayed, they delay that revenue. And what we know is that the revenue coming from increased load can put downward pressure on utility rates. So that starts to become a risk for policymakers and really for all customers as well. The connecting customer faces higher uncertainty and complexity and bigger soft costs, right? And for many of these companies, if you're a fleet trying to electrify, or if you are a charge point operator trying to, build out fast charging for public consumption, the margins are very thin in those businesses. The total cost of ownership is really king, and delays that cause additional costs run the risk of just the project not being built at all. So the risks are very real here, and the sort of business as usual of just like you wait until the grid is built for your site isn't working for many of these customers, and many policymakers are also starting to raise the alarm. So in the paper, what we start with is like, what's the lowest hanging fruit in this system? And the lowest hanging fruit is really we bucketed it into a bucket that we call decision support systems. It's really tools that help customers find existing capacity on the grid, right? So the best solution is to not have to upgrade the grid at all, especially if that customer can move their operations to a site that has existing capacity. And so hosting capacity maps are one tool that many utilities increasingly are using to help with that. Those are customer-facing online tools that help identify areas with grid capacity. Many utilities have hosting capacity maps for distributed energy resources, or DERs, so distributed generation and things like that. EV or capacity maps for load look a little bit different. And so, for example, the example we share here is Dominion Energy, which has a different capacity map for load additions. And Southern California Edison is exploring something similar. So really coming up with a totally different map, because you can use that map then to integrate what you know about load that's going to come onto the system near term. And that can be really helpful for customers. Utilities increasingly are offering advisory services, particularly to fleets, to help them understand where to go, how much is it going to cost, what can I do to use load management to manage my bill, and if I can manage my bill better, frequently the reason that the costs are lower is because the costs to the grid are lower. So frequently with advisory services, you can get the utilities incentives and the customers' incentives aligned. One idea that is gaining some prominence and is sort of about to be standardized in California in particular is the idea of capacity checks. So this is something where before they submit a service application, the customer can go to the utility and pay a fee pre-application to get a capacity check at the location that they're interested in building. That's pretty expensive, right? Because the utility is going through the same analysis as they would after the application. But what it can show the customer is whether there's potential for that site before they do some of the more in-depth engineering that they need to do on their side to complete a full application. So that's something that's gaining some interest. And then also the service sizing refinements. This is, I think historically, utilities have kind of had a worst case planning approach, right? So if somebody's bringing a site onto the grid and they're putting, let's say, 4 megawatts worth of EV charging behind that meter, the utility is assuming that they are going to use all 4 megawatts at a single time, which may or may not be true, and that they are going to use all 4 megawatts like in the 15 minutes or the hour that the grid is the most constrained in that area. And that may not be true. So using data and existing systems, utilities increasingly are honing their load profiles and their assumptions as these customers come onto the grid about how that load that's coming on is going to fit with the existing load on the system. So these are a lot of really low-hanging fruit. They don't they really help eke out existing capacity and sort of get the most from the grid as it is. And more utilities are pursuing these types of solutions, and more customers are expecting them. So the next step up in sort of the maturity curve of these approaches is bridge to wire solutions. And bridge to wire solutions is really about using existing capacity flexibly on a temporary basis while the utility builds the new capacity that that customer requires. And so every time I talk about this concept with utility customers, they say, yes, but it's temporary. It's temporary. That's very important. So it's very important to customers that these approaches be temporary and not long-term, because they want their capacity eventually. So the two that are the simplest here, maybe not simplest in terms of implementation, but certainly simplest conceptually, are mobile asset deployment and phased service connections. So increasingly, utilities are getting authorization to purchase mobile batteries or substations that can be plugged into the grid and support a particular site on the grid until the new capacity is built. One of the advantages of those is that they can then, after they've been used, be redeployed somewhere else. So this mobile asset deployment idea is gaining some prominence. It has some limitations. It's pretty capital intensive. It's not always easy to deploy and then, decommission and then redeploy batteries on the grid. But it is something where we've had some utilities get approval to do some of this stuff. Phased service connections is really the utility saying, we don't have all of the capacity that you want right now, but we'll give you as much as we can, and then, build to that, and then we will build more. And once we do that, then you can add more behind the meter. And so it's really more of a project management approach than anything else. And I think this is working particularly well for some fast charging sites as well as some fleet sites where the customer is anticipating that site ramping up in usage over time, right? So maybe I'm buying 5 school buses this year in another 5 years, I expect to bring another 15 school buses to this same site. But I only really need the charging for 5 this year. And if the utility can accommodate that, then they know that I'm, intending to buy the additional school buses and they can be building the additional infrastructure while that happens. So it's really sort of matching those timelines up. And this is an area where what's most critical is that communication between the customer and the utility. If the customer just submits an application and says, I need to be able to charge 20 school buses at this site without any granularity to like when that needs to happen or how it could be phased, that's going to be harder for the utility to accommodate. So again, this is an area where some of those advisory services and getting that flow of communication between the customer and the utility early can really help facilitate a phased service connection sort of approach. And the photo here is one of ATE's members, Green Lane, which does public truck charging. This is their site in Colton, California, which was opened with 4 megawatts, but they have underground infrastructure to support 12 megawatts in the future. And they opened with 4 megawatts, and the local utility, it's actually a public utility, is in the process of building the rest of the capacity that they will need in the future to be at full capacity. So those are the sort of conceptually simpler ones. The other two are where we get into this notion of flexible service connections. And a flexible service connection simply means that the capacity that the customer has access to changes either throughout the day or throughout the year. So you could envision phased service connection as like, we're going to have the same amount of capacity every day throughout the year until more capacity is built, and then we're going to have additional capacity. With flexible service connections, instead of that flat line until things are built, you have sort of a moving line. With a static flexible service connection, the capacity limits for that site are schedule based, right? So you've got maybe 4 megawatts overnight all the time, 3.5 megawatts throughout the day, most of the year. But in the most constrained times of the year, we're going to give you 2 megawatts. And if the customer can operate within those limits, whether by using behind the meter load management, behind the meter generation, changing their operating schedules, anything like that, then they can get their full 4 megawatts for some of the hours of the year. Dynamic flexible service connections do not have a schedule, and actually the utility uses grid technology and communications protocols to send a more granular capacity limit. So maybe 1 or 2 days ahead, they're saying, okay, today is January 15th. For January 17th, here are your hourly capacity limits. And they're doing that based on the weather forecast, based on real-time loading conditions on the grid, based on what their projections are of what other customers who are served by that same infrastructure are going to be doing during those hours. So it's a much more complex and granular approach. It requires some investment, both from the utility and from the customer, to have the equipment that can make those communications happen. But for customers who are interested in squeezing out every single drop of capacity that they can, it's an approach that's starting to gain some traction. In the paper, we go in depth on these 2 different approaches, the static flexible service connections and the dynamic flexible service connections. I will say all of these examples are from California, and on some level, that's not a surprise. California has a lot of load growth, particularly in EVs. They have utilities and a commission who have been working on load flexibility for a very long time and investing in the systems that are required for that. They also have some pretty significant challenges with grid capacity and with energization timelines. And they have legislation that mandates that the utilities report on their energization timelines. So California had a lot of need and a lot of policy support to get them to the point where the utilities are engaging in these flexible service connections. So for static flexible service connections, what we explore in the paper are Pacific Gas and Electric, and then Southern California Edison. PG&E basically has a program where if you submit a service application and they can't meet your requested capacity, they send you a letter that says, here's what we could do. Do you accept or not? And if you accept, it's a voluntary limit, then you will be what's called load limited, which is that you're operating under that defined static service level. Or you can reject that, and then you can wait for them to build the existing or to build the grid capacity that you've requested. PG&E has more than 100 customers in their service territory who are operating under these conditions, and it seems to be going pretty well. This graph here from RMI sort of shows how a flexible service connection conceptually works. So I'll walk you through it. On the x-axis here, we have the months of the year, right? So from January to December. That top line there at 13 megawatts is the overall capacity of the feeder. The blue line is the existing load on the system. So customer comes in and says, I want 4 megawatts in this location. You can see that from the top of the peak load hour in, looks like July there, to the top of the feeder capacity is only 2 megawatts. Normally, the utility would say, you can't have 4 megawatts. With a load limit letter, or with a phased service connection, they might say, you can have 2 megawatts now while we build the other 2. With a load limit letter, they would look and say, actually, we can give you all 4 megawatts most of the time. There are some times in the year that you will not be able to have all 4 and you will need to reduce down to 2 megawatts. And you can envision, I mean, this looks at the existing load by month, but you can envision if that were more granular, that you could say, actually, even in July, many hours of the day, you could have 4 megawatts. But, you know, these late afternoon, summer hours, you need to reduce down to 2. And because there's a lot of flexibility in terms of EV charging in a lot of use cases, this can work for a lot of EV customers. Southern California Edison's pilot load control management system, or LCMS program, operates similarly. They actually require the customer to have a power control system on the site with the limits actually like coded in and programmed in to that power control system. PG&E doesn't require that, which is kind of an interesting approach. SCE offers 6 operating limits per year, so they select winter, summer, I think, and then shoulder seasons, and then each season has 2 operating limits throughout the day. So you've got, you know, your normal operating limits and then your constrained hour operating limits. This pilot was looking to have about 15 participants. The last time SCE reported on it, they had 6 participants enrolled, and actually 2 of those have exited the program because the grid upgrades that they needed were completed. So I think that's a real success story there in terms of getting customers into the program, but then also getting them out of the program because the grid upgrades have been completed. Dynamic flexible service connections go farther. They are more sophisticated, they're more expensive, and sometimes that cost doesn't actually come with um, additional value for the customers. I've heard customers say, I don't need a dynamic flexible service connection. Give me the static one, make it simple. But for some customers, it's the right choice. So the dynamic flexible service connections, PG&E is the only utility in the country who's doing this right now. They have a pilot called Flex Connect. They offer this to customers who are already load limited, so you already have your hours throughout the day, that they're sort of guaranteeing some capacity. And then they're also saying, if it happens, based on the weather and the real-time loading conditions and the day-ahead forecast, that we have more capacity than that, we'll send you a notice of what that capacity is. And so the day or 2 days ahead, they actually send those capacity limits directly to the customer's on-site equipment using specified grid communication standards. The customer costs for deploying that equipment are pretty high, like $50,000 to $90,000. But if you're a site where that would be valuable, then that might be an investment that you want to make. They've had 23 customers enrolled in this. Most of those are EV sites. So again, we're seeing that the load flexibility that EVs offer tend to be a good fit for these types of programs. And you can see in the graphic down below how moving from sort of a planning limits and sort of business as usual approach to Flex Connect got that customer many, many more hours of their full capacity. I always do like to talk about some of the limitations of these approaches because I think it's very easy to get excited about them. I'm excited about them. They are exciting. But they don't solve all of the problems that we have in energizing customers. And so I think it's really important to acknowledge which of the challenges they don't solve. So one of them is that as deployed today, these are temporary solutions. And again, back to like the customers saying, it's got to be temporary. I need to have my full capacity eventually. What that means is that we're not using them today to avoid grid upgrade costs. They also don't impact service extension timelines. Remember those two reasons why the timeline might be delayed. These solutions are only deployed when there are capacity constraints upstream from the site. They don't impact just the sort of day-to-day work of getting the customer connected, which for all the reasons we talked about, can be complex and lengthy. There's for sure an implementation learning curve for utilities for these solutions. And I think that that's something to not overlook. There's a lot that the utilities that are deploying them have learned along the way. There's a lot of lessons learned that can cross service territory boundaries, but there's also a lot in terms of just like operations protocols and standard operating procedures and grid integration and things like that, that every utility that wants to deploy these will have to learn on their own, and that's going to be a journey. Right now, the scalability of these approaches seems pretty limited. And so that's something that's important to note. Both PG&E and SCE only offer these programs to a single customer on a constrained grid asset. So if it's the feeder that's constrained, the first customer who comes and wants to plug into that feeder and be on a load limit or be on Flex Connect gets to do it, and the next customer who comes along, they say no. So to me, that says that the utilities are still struggling with are not yet prepared, I would say, to integrate additional variables into their calculations of how this could work. And so they're saying only for one customer. And then the dynamic flexible service connection requires a lot of investment on the customer side for the communications equipment, but it also requires a lot of investment on the utility side, in sort of a utility enterprise DERMS system, which is a distributed energy resource management system. Um, More and more utilities are adopting those, but they're very much in the early stages. And it's not something that all or even most utilities have today. So that ability to track everything that's happening on the grid, integrate the forecasts, integrate the weather forecast, and sort of turn all of that into hourly operating limits that you can then send to the customer is a pretty sophisticated approach. Um, what I will say is back to the static flexible service connections, those seem a lot easier to implement, which is not to say they're easy, but easier, and don't require the same level of investment. And so actually California has issued a proposed decision. They're fielding comments on that. I believe those are due tomorrow. So the CPUC has issued a proposed decision for SCE to actually end their load control management system or load control management pilot, and for PG&E and SCE to formalize that flexible service connection as a standard tariffed offer for their customers. Right now, it's all sort of been ad hoc, and they're really looking to formalize it a little bit more. So back to this little map of flexible service connection, or the service application and service connection process. I'm going to show you how some of the things we've talked about influence this process and introduce sort of new and different steps. So the first thing is those decision support systems, the hosting capacity maps, the capacity checks, all of that stuff that asks the question of how can we help find existing capacity on the grid? That can happen in those service application and engineering review steps. It all really like influences the answer to this question in the diamond box of, is the capacity available at the site or not? Bridge to wires solutions do something different. So once we ask this question of, is capacity available, you can see again, if the answer is yes, we go straight to constructing a service extension. If the answer is no, we go to some distribution capacity upgrades. Bridge to wire solutions reorder that process. So now, if the answer is the full capacity is not available, sometimes we can construct a service extension anyway. Again, process that may take some time. But once we've done that, we can use those bridge to wires solutions before we do the distribution capacity upgrades. So it sort of reorders that process and lets the customer come onto the grid even in advance of the distribution capacity being fully there. And there are a lot of thoughts about how these things could be used long term. I'll just say that's still, I think at this point, largely theoretical. I think we're moving towards a situation where you could maybe say, why couldn't a customer be load limited forever? And then we can avoid the need to build the upstream capacity. I think that's a really valid question. I think there's a lot of potential for it. We're not quite there yet. But what it would look like if we could do it, or when we can do it, what it will look like, I should say, is that maybe some customers never have to go through this distribution capacity upgrade process. Maybe they just go into this long-term load flexibility and they live like that forever. I think you would have to you'd have to compensate the customer to do that. Right now, the customers don't receive compensation for bridge to wires solutions. The compensation that they get is effectively they get to plug into the grid faster. The other place that long-term load flexibility could impact this process is sort of in the upper right corner there, where if you have other customers who are already on the grid who have some load flexibility that you're using, for any customer who's coming to interconnect, it starts to influence the question of whether capacity is available. So if you've got other folks on the grid who are flexible in their load, it can open up additional capacity for connecting customers. The last thing I'll go through quickly here is just the recommendations that we had for utilities and for public utilities commissions on this. And, you know, I think for utilities, we want to push utilities to start thinking about this, identify are energization timelines or distribution capacity upgrades, are those challenges within your service territory? What are the right solutions to the challenges that you and your customers actually have? How can you start evolving your operational readiness to start thinking about some of these things? Are there tariffs or rules that would need to be changed in order for you to implement some of these things? We have a couple recommendations around program design and how to think about the granularity of flexible operating limits. And then we always encourage utilities to share their data and learnings. Again, this is a very, very new space. Right now, only happening in California, being explored theoretically in a handful of other places. But, I think as an industry, we'll need to continue to learn together. For public utility commissions, we recommend that they really address this proactively and be flexible and speedy in their process. If this is a problem in a service territory, it is a problem for customers today, and we need to offer solutions as soon as we can. Supporting that research and development at the utility to help support that operational readiness. There are questions around cost allocation and recovery here that are important to note. And then again, ensuring that the Public Utility Commission is playing its role in helping to obtain that's data and learnings from the utilities so they can share them out to other jurisdictions. So those are some of the recommendations that we have. Happy to hear your thoughts on this. I just want to note that I know that flexible service connections are not a good fit for NEVI sites by and large, and I know that's something that a lot of the folks on this call are thinking about and talking about, and maybe sort of like the initial point of entry or understanding that many of you have of EV charging sites. So acknowledge that there are some program designs like the NEVI program that's not a good fit for this. But for other customers, it's working pretty well. So I'll just put this up. I see some questions in the chat. Let's see. From Mary, is it more or less difficult or time consuming for a utility to host a load addition capacity map versus a regular hosting capacity map? I do think it's a little bit more difficult from what I understand, because a regular hosting capacity map, like for generation, is just snapshot of the grid. And the load capacity map also integrates like what we know of the grid today, but also everybody who's in the energization queue, right? Where are they going to be coming on? And so it's a little bit of snapshot of today plus forecast for whenever that customer will be coming on. So that I think is the main distinction and why it's important to have both, but also maybe why the load one is a little more challenging. And then you also asked about Flex Connect. Are they depot and fleet charging sites or public charging sites? I think it's a mix of both. And I think with public charging sites, any load management, whether it's to stay under a demand charge limit, whether it's to optimize to a TOU rate, whether it's to participate in a flexible service connection, that customer needs to consider their own customers and the experience they're going to have on site if they pull up and there's power sharing between the chargers because you're load limited in those hours or something like that. So I think it has to be a really careful conversation between the utility and the customer to make sure that that's the right solution.
Thank you.
Looks like Stephen has a question.
You mentioned transformers earlier in your presentation. Has the delay, does it match what we thought it would be when a year or two ago when we started this? And does the change in the administration's emphasis, is that expected to change that?
That's a really great question. I have continued to hear that there are delays in obtaining transformers. Um, I have not heard anything affirmatively about the change in administration having an impact on that. But if others have heard differently, I'd be really curious to know the answer that others are hearing. I haven't really heard anything one way or the other.
Thank you.
I have a question. What's an example of a fleet that might be a good fit for dynamic flexible connections, like in terms of their duty cycle? Just trying to think of like what kind of fleet might be a good fit for that, given that it could be kind of challenging to plan around. But yeah, just curious.
Yeah, it's a good question. So one of the customers that is on, is public about their participation in Flex Connect is Tesla. I believe they are participating both with their public charging sites for light duty as well as with a charging site for a fleet that uses some of their semi trucks. Um, and I'm not really sure the answer. I mean, you'd have to have a duty cycle that doesn't require you to charge during those like summer afternoon and early evening hours. Um, One of the things that people have thought about is like if your flexible service connection, like you have to have enough capacity for enough hours to get enough kilowatt hours into your trucks, right? If you're a fleet. And so, does the flexible service connection allow for that in the hours that your fleet is not on the road? And that's kind of an interesting question. I think the way PG&E has identified it is they've said, look, this makes sense for customers who have a lot of flexibility in how they use their load. They really want to come online very quickly. Um, and they have and they're going to use a lot of load or they're going to do a lot of charging in the off-peak hours, right? Like it has to kind of be big enough to justify the investment, that like $50,000 to $90,000 investment in the communications equipment. So they've been really clear this isn't right for everybody. And we've talked to, others of our members who are customers of utilities that say, nope, would never want that. Too expensive, too complicated, doesn't give me what I need. I will go with the static flexible service connection. I can understand it. It's not that different from like how you might think about a time of use rate with these like time blocks, right? Um, and just operationally, they didn't think sort of like the juice was worth the squeeze, right? But I don't quite know the answer, and I think we'll start to get more data out of California as that pilot continues. Okay, I've seen some more questions. Oh, hi, Kathleen. Um, Bidirectional charging. Um, so that's a good question, and about would Flex Connect work better with bidirectional charging, allowing fleets to put energy back to the grid? Um, And I'm trying to think about exactly how that would work with Flex Connect. I think one of the things that we're hearing is that with some of these flexible service connections, what does make sense is behind the meter generation, um, or batteries or things like that that can help the customer participate better in the program. Obviously, those come with their own costs, right? Whether those are dollar costs or emissions costs or whatever else. Um, I'm not quite sure how Flex Connect would work with bidirectional charging. I do know that once you're using, um, batteries or behind the meter generation to, export to the grid, then you're in like a whole other category of engineering requirements to even get that site connected. So I'm not quite sure how it would work, especially because, again, all of this is intended to be on a temporary basis. But I might try to track that one down and get back to you, Kathleen. Mary asked, what kinds of permissions do utilities need from their PUC to enable some of this stuff? So for mobile asset deployment, that is definitely something that if the utility is going to be, investing in capital to purchase assets, that's going to be sort of like a general rate case question or some of that's been approved through proactive infrastructure investment. Phased service connections probably do not need PUC approval. PG&E started doing its load limit letter program without any PUC approval. They just said, we can do this. It was just a change to their process. They said we can do this better. And again, now the PUC in California is asking SCE and PG&E to formalize and standardize that into a tariffed offer. So it would be like, here are the conditions under which it's offered, and here's how it works, and here's what the enforcement mechanism is, right? You might remember that SCE requires a power control system at the customer site. PG&E does not. And so there start to be questions about if the customer went over their limit, what would happen? Who would bear liability? How does the utility catch that and prevent it from happening again? But I think PG&E has been able to do enforcement just basically with like conversations with the customer, which like works in small scale deployment, but doesn't scale very well. And obviously, there's some risk there. So the answer is I think utilities can move some of this stuff forward without PUC involvement. I know that customers and others in the space, as soon as utilities are doing that, they want some PUC involvement to like track outcomes and how is it working and how many people are involved or how many customers are enrolled and what are the data and learnings, right? So sometimes the PUC process isn't just for like putting the stamp of approval on something, but actually for like collecting information about how it's going and sharing that out in a more transparent and public way. So there's some value to a PUC process for those reasons.
Thank you. I want to ask two follow-up questions. One on the phased connections or what if do you need PUC involvement if you say you need 4 megawatts all the time? We can give you 2 now and 2 more in 5 years. Do you need PUC involvement for that? Or so the customer could start building to the 4-year capacity, but just not turn that stuff on, So how does that work?
Yeah, I think that ends up being, I think the way the utility ends up constraining that is at the service size, right? So they would give them the lower service size now, and then that puts the risk of, overbuilding your service size, like behind the meter effectively, right? The customer would take on some of that risk versus building the larger service size, even if you don't have the upstream capacity to deliver that. So I don't think that one requires a PUC approval, though. I think it's really just maybe a tweak. A lot of this feels like tweaks to processes and culture within utilities of sort of creative solutioning.
Okay. And then have you worked with I know a lot. Have you worked with any consumer-owned utilities on any of these strategies? Because many states have a few IOUs, investor-owned utilities, but lots of consumer-owned utilities, and not clear how these kind of strategies apply there. But we need the consumer-owned utilities problems addressed as well.
Yeah, absolutely. So obviously those wouldn't be, through a PUC process. I think so that Green Lane site in the city of Colton in California under a phased service connection is it's a public utility. And so they've been able to make that work. I imagine that the biggest hurdle is going to be the cost of sort of utility equipment, and ability to kind of like run the back end of these programs, right? Like, is a PUD gonna invest in an enterprise DERMS system? I don't know. Like, it seems unlikely, right? So I think that particularly for smaller utilities or those that sort of are not regulated in the same way, the question starts to become sort of like costs and trade-offs and um, bandwidth and things like that. That's what I would imagine the hurdles are. But not all PUDs are small either, right? So like I could certainly see some of the larger ones saying, yeah, this is worthwhile for our customers um
So
and
we've
to
got
to
the
streamline our
munis,
timeline.
right, right, right. And I don't want to take up all the time, but I just do you know, do you have counterparts in other associations that are working on these kind of solutions for consumer-owned utilities, whether they're municipal or PUDs or co-ops or any of that? Do you have any clue?
I mean, uh I think this is very cutting edge. So I think it's going to gain some prominence over the next couple of years. Like, I think this is one of the first papers, maybe it's the second paper that's been written about this concept. EDF had a paper out last March, I want to say, exploring this. And I know of a handful of other sort of think tanks and trade associations that are all preparing papers on these topics. So again, I think it's something that's going to grow in some prominence, but certainly has not been super widespread outside of California at this point. Yeah, Kathleen.
Uh, Thanks and hi. I was gonna point out just to Mary's question about the customer-owned utilities. I think that part of the issue is, and every time, and Elizabeth, every time you said the utility pays, I cringed a little because it's not actually the utility who's paying. They are getting significant rates of return from their customers on the rate base. And the reason that those customer-owned utilities are not moving forward with these things as quickly is because they don't have the ability to make that investment in the same way because their customer base is so much smaller. And I think that's something that folks, and when we think about utilities as one of the only PUCs on the NASEO calls, usually, I think it's important to point out a lot of times they just don't have that customer base. An IOU can rate base these solutions and it's a couple of dollars a month on everybody's bill. You do that on a municipal utility, you're talking about a couple of $100 on everybody's bill. And that's part of that disconnect.
Yeah, I think that's where small size and there are some investor-owned utilities that are not huge, right? And like it's notable to me that it's two of the biggest utilities in the country that have sort of started this. So yeah.
Great.
All right.
Well, we are
Sorry,
a little
Delaney, I
over
know
time.
we're over time here.
Oh, no worries. It's been a great discussion, really helpful information, and glad we had so many great questions. But want to thank you again, Elizabeth, for sharing your insight. Like I said in the beginning of the call, we'll send out the recording and the slides to you all for your viewing. But thanks everyone for attending this call and look forward to chatting with you all in March. But hope everyone has a great rest of their day. Thank you.
Thank you.
Thanks, Delaney. Thanks, everyone. Feel free to
Bye.
reach out if you have questions.
Thanks, Elizabeth. Nice to see you.
You too, Mary.